Hi, welcome to my video on continuity as extra problems. Number one, the f of x is a piecewise function where we have the quadratic ax squared plus bx plus 1 when x is less than or equal to 1. And we have as a linear bx plus 3 where x is between 1 and 3 but equal to 3. And it's a linear 2ax where x is greater than 3. Find the values of a and b if the f of x is continuous at 1 and 3. So the f of x is continuous at 1. So 1 is on these two. So the limit on the left equals the limit on the right. So let's do the limit of the f of x as x approaches 1 on the right. So the limit f of x is x. Oh, I got f of x here again. I'm going on the right. Right is here. So this should be a bx plus 3. So this is on the right. Bx plus 3. 3, 2, 1. This is the right side, the upper side. So this is the one you have to use. So we're approaching 1. So b is 1 plus 3. So that's b plus 3. And now the limit on the f of x. Here was the right, so that's x approaches 1 on the left side. So that's the limit. On the left side is here, less than 1. So we have ax squared plus bx plus 1 as x approaches 1 on the left. So we put 1 in the place of x. There it is, sub into 1. So that gives us a plus b plus 1. And because it's continuous, the limit on the right equals the limit on the left. So that means that b plus 3 is equal to a plus b plus 1. And the b is on each side, so we can cancel. So a is equal to 3 minus 1. A is equal to 2. So we can put a 2 in here and get 4x and then work it out for 3. But let's go through the limit of the f of x when x approaches 3 on the right side. So let's look at when it's continuous at 3. Oh, I got f of x again. 3 on the right side. This is 3 is greater, so that's 2ax. I gotta be careful. Sometimes I slip f of x in here each time, but it's the function I have to put in. So x is 3, so it's 2. X is 3, so that's 6a. And the limit of f of x as x approaches 3 on the left side. Again, see, I did the f of x. Oh, this is okay this time. When I rewrite it, I had to put it on the left side of 3. So this is the left side of 3. So this is bx plus 3. Just got to be careful as x approaches 3 on the left side. So that's 3. So we put 3 in the place of x, so it gives us 3b plus 3. So that means in relation to being continuous at 3, the right side equals the left side. So that means 6a plus 3b. So 6a equals 3b plus 3. So that means I can solve this for a and b, but I know up here that a is 2. So a is 2, so I can put a 2 in here. So that gives us 12. 3b plus 3. I'll leave the 3b there and go 12 minus 3. So that's a 9. Divide by 3, so b equals 3. So this function, the a value is 2 and the b value is 3. That's the values of a and b where this function is continuous at 1 and 3. So we took 2 and 3 and subbed in here. B is 3 subbed in here, put 2 here. Then at 1, this value would be equal to this value. And if you put 3 in, the two values would be the same also. So this is true when A is 2 and B is 3. Okay, let's look at another one. I've tried to make up something a little tiny bit different but similar. We have a Wx is a piecewise function as a quadratic kx squared plus 4x minus 4 when x is greater than negative 2. And this is a linear 2x plus qx plus 2 when x is less than or equal to negative 2. So the Wx is continuous at negative 2. Find the values of k and q if k and q belong to the natural numbers and q is greater than k. So we've got some restrictions on the q and the k's. They're natural numbers. Let's look at it. So if it's continuous at negative 2, that means the limit of Wx as x approaches negative 2 on the right side. So let's see, on the right side is this one. So we got a k x squared plus 4x minus 4 as x approaches negative 2 on the right side. And that gives us, we're going to put a negative 2 in here for x. And we have that done, so that's 4k minus 8 minus 4. So 4k minus 12. Now let's work out the limit Wx as x approaches negative 2 on the left side. So the left side, just got to be careful. Left side is right here on the less than negative 2. So we got 2x plus qx plus 2. And x is approaching negative 2 on the left side. So negative 2 goes in the place of x. Negative 2 goes in the place of x. That gives us negative 4 minus 2q plus 2. And we get a negative 2q minus 2. And the limit on the left is equal to the limit on the right. So that means this is the limit on the right. So we get 4k minus 12. And the limit on the left is negative 2q plus negative 2q minus 2. So we have values of k and q, but we don't have any more conditions. So we got how are we going to find? Well, let's look at it. It says that k and q belong to the natural numbers. So natural numbers are 1, 2, 3, 4, etc. So we could solve this. These are the natural numbers. So that means that k and q belong to the natural numbers. So let's solve. We can solve this one for whatever. Let's solve it for q. The reason I'm solving for q because 2 will divide into 4, 12, and 2. So move the q over to the left. Move the k to the right. Move the 12 to the right. And when I do, I'll get a negative 4k plus 10. So divide by 2, q equals negative 2k plus 5. Now, it says that q is greater than k. So if q is greater than k, let's start off k. K is natural numbers like this. So if q is greater than k, let's let k equal 1. So q equals negative 2, k is 1. So q is negative 2 plus 5, q is 3. So the values of k and q possibly is that k is 1, q is 3. So let's look at the next value. K is 2. So Q is negative 2. K is 2 plus 5. So that's negative 4 plus 5, which is 1. So that K is 2, Q is 1, but Q got to be greater than K. Q is not, so K can't be 2. So if you put a 3 in here, then the number is going to be negative 6 and 5, so that's a smaller number. So they can't work. So these are the values that work under having the natural numbers, and K has to be 1 and Q has to be 3. That's the only possibilities if they're natural numbers, and Q is greater than K. Okay, that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.